Remember from our ASCII lesson that a byte can be either 0 or 1. You may also recall that 8 bits make up 1 byte. If you remember this, it will help you a lot going forward. We also discussed how computers use multiple bytes to represent different characters, symbols, and shapes. If that sounds familiar, good job. Computers use bytes to store files and documents in their storage system. The more bytes a file requires, the more space it occupies. Let's begin by looking at the smallest unit of measurement in digital storage. A bit is the smallest unit of data, and it's either a 0 or a 1. 8 bits make 1 byte, and a byte can represent a letter, a symbol, or even a small shape. I'm not going to dive deep into that again. This is just a quick recap to get the ball rolling. When you have 1,000 bytes, you get 1 kilobyte or KB. You usually see KB sizes with text files. For example, if you open Notepad, type a long paragraph, save it, and check the file properties, you will see the size listed in KB. Now, when you have 1,000 KB, that becomes 1 megabyte or MB. It's called mega because 1 MB equals 1 million bytes. Most of the files we deal with every day, like images, audio, and short videos, are measured in megabytes. When you have 1,000 megabytes, you get 1 gigabyte or GB. That's 1 billion bytes. You usually see gigabytes when dealing with large files or high-quality media. This is also the unit you see when buying a phone or a laptop to check how much storage it has. And it's not just storage. RAM is also measured in gigabytes. Now, what do we get if we have 1,000 gigabytes? Any guesses? That gives us a terabyte, or TB, which equals a trillion bytes. Terabytes usually come into play when you're dealing with servers, huge amount of data, or computers with very large storage capacities. Most people don't really deal with terabytes unless they're producing a lot of data and need somewhere to store them. After terabyte, we have petabyte. 1 petabyte equals these amount of bytes. This is extremely rare for everyday use. You will usually hear about petabytes only when talking about internet giants like Google or Facebook. So far, we've covered kilobytes, megabytes, gigabytes, and terabytes. But here's where things get interesting. Have you ever heard of kibibytes, mebibytes, gibibytes, or tebibytes? Here's a twist. Kilobyte, megabyte, gigabyte, and terabyte are not exactly based on 1,000 the way most people think. In reality, 1 KB is 1,024 bytes, 1 MB is equal to 1,048,576 bytes, and so on. So then you might ask, why do we keep using 1,000, a million, and so on? The reason is simple. People already understood that kilo means 1,000 and mega means a million. It was easier for them to remember, so the term stuck. To clear up the confusion, the International Electrotechnical Commission, or IEC, introduced new terms: kibibytes, mebibytes, gibibytes, and tebibytes. These represent the true binary-based sizes. The idea was to let people use kilobytes and megabyte for the base 10 numbers and use kibibytes and mebibyte for the exact sizes. But in reality, most people still use KB or kilobyte and megabyte for everything. What can you do? Now you know the different units of measurements for storage. You can understand why games and high-quality movies take up gigabytes. And the next time you buy a computer or a phone, you'll know how much storage you actually need. If you found this video helpful, don't forget to share it with friends and family so they can benefit from it as well. See you in the next one.